attention. This is great. We know our first quadrant. Did you guys get this one?
Yeah.
Yeah, almost easy.
All right. Let's just walk through it. No. Remember, it's the same thing as saying A plus 2B is what, 20? Intercepts of 10 and 20. And then 12 and 8, thank you. Respective, yeah. Oh, this is the 8 on this side. Wait a second.
The 20's on the bottom. The 20 was on the
Yeah, I was like, wait a second, I'm backwards here. I'm wondering why it looked weird. Bless you. That was what? What'd you say, 12 and 8?
8 was the bottom one. 12. Sorry.
That's okay. And your intersection point when you set that up was what?
2-9.
2-9? Yeah, that's right.
9-2. I got 9-2.
Well, here's the thing. Shh, guys. Are your axes flipped?
It's flipped, yeah.
Then that's fine. Then you're right. What happened here with Mr. West, his ordered pair, he's like, mine was 9-2. Well, his axis is flipped. And as long as you kept everything consistent, you're going to be just fine. Okay? When you do your constraint, you after through, I'm assuming you wound up with 2-9 as your max?
Yeah. Is that always going to be your max to the point?
No. Not always. Kind of. More often than not, but not always. Then we had, after that, the orange drink.
I think
The orange drink, the only thing that's weird with the orange drink is the fact that they're using the letter O, and they're talking about orange aid, and they use orange juice, and it's too many different same variables in this one.
Aren't you glad that they didn't go any deeper?
Ah! Well played, sir. Well played. So we have orange drink and raspberry drink, and we're making smoothies or something. Ladies and gentlemen, as you go through this problem, remember yesterday I talked about the need of being able to convert things from quarts and gallons into quarts. The only time you have to do that is at your two constraints about the amount of, you had 125 gallons of one of them and 600 gallons of the other, or excuse me, 125 quarts and then 150 gallons and 125 gallons. Convert those to quarts and keep everything in quarts. And at the end, you just convert back. It's a little bit easier that way. So you're trying to maximize your profit. And your profit wound up being, what, 0.5 for the orange. I'm going to use OR for orange. Ladies and gentlemen, there's a lot here today. And 0.4 for the berry. And then we had our two values. You had one of the drinks used 2.5 quarts plus 1 quart, and that had to be less than or equal to the 125 gallons of orange juice. So this is my orange juice. So I'm going to write that as in quarts. All I did was just multiply it by 4. Instead of it being less than or equal to 125, I wrote it as less than or equal to 500. That way everything is in the same dimension, whatever. And then the other one is 1.5 of the orange plus 3B is less than or equal to now 600 quarts, and everything's got to be greater than or equal to 0 for your orange and for the berry drink. So when you get this far, were you able to get those equations without too much of a hassle, I hope?
No, I got
Good. Remember, when you're looking at these problems, the easiest thing to do is figure out what are the two things they're talking about. Sometimes there's 3 things they're talking about. In this case, you're talking about orange juice and berry juice to make the 2 flavors. Your constraint is how many gallons of each type that you have. So you put them together for each flavor to set up to the overall usage. And then it's just a matter of plotting. It's kind of weird when you have the decimals in this stuff, but once you start dividing things out, it shouldn't be that bad. I put my orange here and the berry here. I have intercepts of 200, 400. Okay, I'll do the first one first, excuse me. 200 down here for the, and then 500 for the first equation, to the inequality. And then the other one was 200, 400. Everything's moving inward again, where our signs are working. And then we have to find their intersection point. In this problem, it's kind of set you up to use substitution. Do you have to? No. But does everybody see how you've got a b with the coefficient of 1? If I use that with the coefficient of 1, say b is 500 minus 2.5 orange, it's a little bit easier to solve for in the long run. Don't try to do linear combinations if you don't have to. It's not that they're that difficult, but sometimes you might get lost in the decimals and the fractions and whatnot. So you multiply this one out, we get 1.5 orange plus 3 times the quantity. So when you set all that up, you wind up with 150. You're going to need the masking tape soon, too.
Yeah, I don't know why.
Did your batteries fell out? Take it back.
Okay, that was really surprised. I was really confused by these 3
I know things are difficult for you. So your orange value is 150. That's the x coordinate at this point. When you substitute that back in to solve for b, you wind up with 125. And then it's just a matter of going through your 4 ordered pairs. Someone found the mistake they made. 0, 0, I'm thinking that's not going to work. 200, 0, 150, 125, and then 0, 200. When you work it all out, I do believe you should get the 150, 125 as the ordered pair as your maximum. Did anybody get the last problem? No. Did you get like a crappy decimal?
Yeah.
Okay, and that's
Oh, I did.
okay. If you got a crummy decimal, you did it right because can you make? You didn't get a crummy decimal? You got it cleanly? I got every well. Every time I did it on the last one, I kept doing it getting a crummy decimal around that one. Did yours work cleanly? Okay. You forgot your third. There was one line in that last one that said you had to have 3 times as many sauces as you did tomatoes. There's a third line, yeah.
What if I went like this direction? Does that still work?
You're still missing the third equation in this one.
Oh, there's
There's a third equation. Guys, remember I said on 34, or excuse me, on 23 here, there's a third equation in this one. So if you got the crummy decimal, you remember the third equation. T had to be greater than or equal to 3 times the amount of salsa in here. The farm stand wants at least 3 times as many jars of tomato sauce as salsa. Okay? So when you work all that out, you do wind up with crummy decimal. It's like 4.6 or somewhere around that, or somewhere in that neighborhood. Is that what you got? You're nodding? Okay, then you did it just fine. When you go back into this problem, sorry about that. When you go into this problem about the canning, so you have a limited amount of tomatoes and onions, your tomato sauce, and your salsa. You have a total of 180 tomatoes and 150 onions. I love how they use the letter O's all the time here. It's like, come on. That's why I lost it on my line here. Onion, 15 onions. There you go. So it's not a lot of stuff to make stuff with. So you know that with your tomato sauce, it takes 10 tomatoes and 1 onion, and you make $2 profit on it. On the salsa, it needs 5 tomatoes and 1/4 of an onion, and you make $1.50 off of it. Okay? So now what you're doing is way that I wrote this up, see how the tomatoes are already set up in terms of what you can only use? I can only use up to 180 of them. I can only use up to 15 onions. And I have left over my profit. And I'm trying to maximize my profit. So our profit is going to be $2 on the tomatoes plus $1.50 on the onions is going to equal our profit. All right. From that, we just write up the other ones. 10 tomatoes plus 5 in the salsa. It has to be less than or equal to 180. That's for the tomatoes. 1 onion in the tomato plus 1/4 onion in the salsa has to be less than or equal to 15. Really boring salsa if it's just tomatoes and onion.
Yeah.
Got to be greater than, but there was one thing it said that you want to have that function. 3 times as many as the other. And that's where this will lead you out. If you were getting 12-12, that's great. But if you didn't get the diagonal, that's where things will get a little messy here, because it says he wants 3 times as many as the other. So this winds up being a little bit messier, kind of like that one we did yesterday with the sheen with the 3 parts, and then there was that 3rd line or that 4th line we had to throw in there on the diagonal, figure out where it laid within the our functions and parameters. So you grab everything else, it works out nicely for your intercepts through the rest of them. What gets messy is that 3rd one. So let's see, I have tomato, salsa. Let's see, you get 15 and 75 for one of them, and 18 and 36 for the other. So here's 18, 36, and this one was 15 and 75. And were those 2 points met? Yes, those you guys that gave me 12-12 is correct. That's where the intersection of those 2 lines. All right, so that was a correct spot. Everything's working inward. But the trick here is that you want the t value to be 3 times as many as the salsa value. So if 3 times as many salsa is the t1, you have to redraw that next line to figure out where it's going to go. All right. Excuse me. So if you think about your values of t, if I say t is 12, just for example, if t is 12. If t is 12, that has to equal 3 times the s. What's the value of s? 4. So if t is 12, the value of s is going to be 4, so it's going to be lower then, right? So that means that that 3rd line goes below it. Does that make sense?
Yeah.
It's going below that value of 12-12. I'm using that as a little bit of a test point to kind of get a gauge of where it's going to line up within those two other parameters. Now comes the weird part of finding out where that part hits, because once we figure out this spot, that's where you get kind of that weird ugly decimals, like 4.6 and change. When you substitute it to hitting this line here, you know that t is 3s. So if I'm looking at the 75 and the 15 line, that is this one here. When I look at that one and I substitute in, let me this up real quick. I get 3s plus 0.25s is 15. So you wind up getting s is 15 divided by 3 1/4. You get this weird decimal. So what happens here is that you kind of have to say, well, I can't make 0.6-ish jars of salsa, can I? So you round, yeah, you can try. So you have to round down. That's why they're saying use 4. Okay, that's where, if you looked in the back of the book, you saw the ordered pair of, I think, 14 and 4, I want to say. That's why they're saying to round down. It's one of these weird things that happens. If you got the weird decimal, you did just fine. Now, when we come to a test and or quiz on this stuff, am I going to make you have to realize rounding error and stuff like that on that? No. Okay, no. My goal for you guys on this problem was to see if you can identify where it winds up lying within the actual graph itself. When we get to test stuff or quiz stuff, if there happens to be a problem like this on there, it will not be this crummy decimal. Okay? It will not be that decimal. All right? Is that fair? Good. Are we getting better?
Yes.
If I give you 4 of these that aren't with the third parameter on it, would you be okay?
What is considered okay?
Well, how many of you guys are rather comfortable doing the problem that looked like the cabinets? Okay. If you had 4 problems along the same lines of the level of difficulty of cabinets, would we survive?
Yeah.
Would we be able to go on to something new starting Monday?
Yeah.
Sounds like a plan. So, here's how these things start up. Don't lean back in the chairs. These Louise, you're gonna break them. All right. So, if we go through the first problem, it says airline sells business class and tourist class seats for its charter flights. To charter a plane, at least 5 business class tickets must be sold and at least 9 tourist tickets must be sold. The plane does not hold more than 30 people. They make $40 profit for each business class and $45 profit for each tourist class ticket sold. In order for them to maximize profits, how many tourist class seats should they sell? Now, when we go through this, what I want you to think about, well, what's the first thing that you know? You know that you're trying to maximize what? Profit. Okay, so if you're trying to maximize profit, we need to go ahead and start writing that out in terms of your profit, right? So let's see, we have, you have business class and tourist class, right? B&T, business and tourist. How much do you make on business again?
40 bucks.
Q1 just said 45 bucks.
Okay. Now, it said that you had to have at least 5 business class tickets and at least 9 tickets sold of the others. So that means your business class has to be greater than or equal to how much? 5. And your other one has to be greater than or equal to 9. Now, is there a top as far as the combination of those two is concerned?
Yes.
How many?
30.
30. So these two have to add up to be less than or equal to how much?
30.
There you go.
Is that an L?
Oh, it's a T. Oh, it's like an upside down seven though.
You got some
Okay. So that's setting you up right there. This one should be really, you have two, you have a horizontal, vertical, and a diagonal. You make a triangle. Okay. You wind up making, in the number 2, same idea. You've got a horizontal, a vertical line to worry about. You've got a diagonal, and a very simple profit function. What else is there? We're doing 3 is the dance theater. They're all so cheesy. The fun air.
So we're not doing 5.
Yeah, just don't do 5.
We can just cross that out.
That's fine. Do 1 through 4 on this one. Give them a shot, guys. You should be okay by now, I hope. Yeah.